Happy Tuesday, folks. Today we're going to talk a little bit more high level than maybe you're used to with one of our Markforged webinar. We're going to talk additive vision. We're going to tie it back in kind of industry wide and then bring it back to talk about the digital forge, which is Markforged solution as well. And try to kind of give you a holistic overview of what is additive in 2022, why should you care, how can you actually affect change in your business, and what does Markforged do to offer that help. But first, a super quick note about ourselves. I'm Daniel. This is me like 5 years ago with much shorter hair. I work in product marketing, but I have a mechanical engineering background. I kind of learned about 3D printing and learned 3D printing when it was in kind of its early and nascent phases, and have been here for a long time, kind of helping educate folks, whether they be manufacturers, engineers, people who know nothing about printing, about why it's valuable, and why you should think about it. And this is Nate, and I'll let him introduce himself.
Hey everyone, I'm Nate Samson. I'm a strategic application engineer here at Markforged. I'm doing this for about 3 years. Previous to this, manufacturing experience in automotive, power generation, aviation, and have firsthand experience of implementing additive in the manufacturing world. And excited to discuss our vision here at Markforged.
Great. So super quick an agenda. I kind of went over it in very quick words, but we're going to talk about additive as it is right now, where it's at and how it got there. We're going to talk about how it can transform your business and what business transformation, which tends to be a really big buzzword that just about every emerging industry uses, actually means in the context of additive manufacturing. And then Nate's going to take you through two really great steps that are much more actionable. First, how do you build an additive plan? What are the things you should be thinking about? What are the things you shouldn't be thinking about? And then last, how Markforged can help. We're not going to talk about it in broad strokes. We're going to talk about tangible features that Markforged has that kind of enable that broader adoption, that enable that transformation in ways that maybe other folks don't. So first, additive in 2022. So let's start with the chart that is most associated with every emerging technology ever, the Gartner hype cycle. I would presume that you've seen this before. I've certainly seen it before. It's been linked heavily with 3D printing probably since about 2010, if not earlier. But it's really accurate. And, it's one of those things that is popular because it's good. And in my experience, this chart is really used heavily in two contexts. The first is when something is at the top of its hype cycle, and it's used by analysts to say, hey, maybe we're overdoing this. Maybe we're spinning up a bit too much. And it was certainly used by 3D printing in that context about a decade ago. And the second is it's used really heavily by companies who are in an emerging industry that's currently in a stage of disillusionment or climbing that plateau of productivity to show that, maybe it was overhyped, but now we're coming back. And, we at Markforged are extremely guilty of using this exact chart for that exact purpose for a long time. But I think, now that we've been using it for a long time, we're rather vindicated in that. We believe that this is actually true. If you look at how additive has evolved over the last 5 years, it's pretty closely mirrored that kind of second slope of that cycle. So to zoom in a little bit, I think this is the kind of the most underappreciated, but the most important part of that hype cycle. We talk about how people get really excited about stuff, they overhype it, and then it kind of goes into the ditch. But what actually, and that happens with most technologies in some way, shape, or form. But what actually is a larger indicator of the success of a technology or a set of products long term is how it climbs that plateau of productivity into the mainstream, or maybe more importantly, whether it does climb that productivity. And there's a bunch of key actions that both players in an industry can take, but then also users of a new technology can take to help something climb from being a semi-productive but a disillusioned technology to something that's in the mainstream. And what we've been seeing in the last 3 to 5 years is that additive has been really, really quick, like slowly but steadily climbing that slope. And so to give like a super quick time box, we kind of believe that, about 4 or 5 years ago, we kind of exited that disillusionment stage and entered into this kind of gradual gain of companies really starting to adopt it in a meaningful way. 2020 was a sea change moment when the pandemic happened and enabled much greater adoption of additive and also a much larger refactor of how we think about things are made. And our posit is that 2022 is kind of the year that additive is entering the mainstream. And granted, these are all very hand-wavy things that are not related to actual metrics. And the engineer in me is kind of cringing at the fact I'm saying, like all these kind of arbitrary points. But I think it actually holds meaning. And I want to show how it holds meaning in a few key ways. So the first is, what does additive look like in 2022 and why are we saying it's in the mainstream? So first is, where are 3D printers? So the first example is that 3D printers are on engineers' desks everywhere. Whether they be cheap printers, expensive printers, engineers more than ever are having direct access to these machines so that they can make parts at their point of need. They have a problem, they have an idea for a solution, they try to solve the problem with the 3D printer. And 3D printing is unique in its ability to solve problems in that way. And we're starting to see that mass proliferation of engineers in the workforce that have worked with 3D printing, that are experienced with 3D printing, and that want to use it to solve problems above other methods if they can. The second we see is that the 3D printers are finding their way into manufacturing floors, whether that be a small machine shop, whether that be a huge manufacturing floor of an automotive facility. They're starting to become a piece of furniture in this much larger ecosystem. And that's a really important thing. You know, I don't think most people would be excited about their things just being a piece of furniture in a factory. But for us, you know, this is a technology that for a long time has not been seen as something that's fit for manufacturing. But we've seen over the last 5 years, especially, is that an increasing number of folks are just putting these things to work in manufacturing just as another member of another tool in their toolbox. And that's an immensely valuable thing. And it goes across all scales of businesses. And the last one we want to talk about is that 3D printing has found its way into education in a really meaningful and significant way. So this is an example of someone like a Saskatoon Polytechnic Institute in Canada who are teaching their students, whether they be in clubs or in classes, about additive manufacturing. You know, you learn about DFM in college as a mechanical engineer, and now people are starting to learn about design for additive manufacturing. And that's a big step forward. That means that the next generation of people who are working and the people that are currently entering the workforce are additive native. And when you think about that in the context of the previous kind of big step forward, which is CAD or digital CAD, that really fundamentally changed how things were made. And we believe that, you know, the way that additive has penetrated so aggressively into that education sphere yields long-term dividends as it being a mainstream technology. We see this as well in the terms of the conventional press. You know, for years, additive has been a technology that has had a really healthy market of industry publications that talk about really interesting and compelling things, but is not really broken out into the mainstream, except for maybe a stray TechCrunch article. What we've seen in the last couple of years, especially spurred on by the pandemic, is that large publications that have significant interest beyond just manufacturing are thinking about additive in not just a hype cycle way, but in a meaningful way. You know, 10 years ago, you might have seen New York Times write an article about printing Yoda heads or you know, the first MakerBot. And now you're seeing them talk about inching closer to production parts for car makers. Wall Street Journal is basically echoing every 3D printing company's like core messaging when they talk about how 3D printing assuages supply chain things. And you see headlines everywhere that are, this technology looks bright for 2022. And so these are the type of things we like to see, whether it be that broad approval that you see kind of, you know, puncturing that bubble within an industry, or just that specific outlook of this is the time. And so that's why we think it's the mainstream. To boil that down, there's 3 keys to success here in terms of a mainstream technology. The first is broad adoption across a lot of verticals, whether that be the verticals that are easy to penetrate, those early adopters, first movers, or the more controlled industries like automotive and aerospace. These are people who have not been adopting additive, who are now thinking about adopting additive. The second is C-level initiative buy-in. This is really big. You know, additive initiatives are starting to find their way onto executive leadership team desks, not just engineers' desks. And the last one is that on a fundamental level, additive is being trusted by its users. That can mean engineers, that can mean fabricators, that can mean students, makers, what have you. But people who use additive understand additive. And, you know, it is a limited technology as any technology is, but they're starting to use it in the right way consistently the first time. And those 3 things kind of drive something to be a mainstream technology as opposed to a niche technology. But what has enabled this? So, you know, things generally evolve, and if you have a solution and more people adopt it, it will inherently become a more adopted solution, but it might not be a better solution. So throughout the last 5 years, as we've climbed this plateau, additive has quietly really leveled itself up, whether that be through its better materials availability, and that includes both plastics, metals, specialized polymers, all that kind of stuff. Its reliability, going from, you know, machines that work sometimes to machines that work nearly every time, whether it be the machines themselves scaling up, then becoming more easy to use, or becoming more connected to the world around them. They're starting to become a part of that manufacturing fabric in a way that subtractive machines struggle to, because additive is inherently automated and inherently connected. So when we think about this next generation of fabrication, additive is the type of technology that people want to base their operations around from a tech stack perspective. And that is hugely impactful. But what does that mean in the context of business transformation? So I want to kick this to Nate for a second to kind of introduce some stuff, because Nate has some really powerful experience in terms of what it actually means to transform a business. So Nate, I'll kick from here.
All right, great, thank you. So right, this quote here by Grace Hopper has had a lasting effect on me. So this quote was actually pasted on the wall at a previous job that I had in the manufacturing industry. And it was actually requested by a few of the shop workers who truly believed in bettering the business and innovating. They truly were tired of hearing, we've always done it that way. This was when additive was starting to get adopted at the facility. And this really truly has stuck with me. And I think more people should see this and have it plastered around to drive the right culture and drive for change, whether that's additive or other things. All right, so successful businesses encourage change and empower their employees to do so. So change for the sake of change isn't effective. What meaningful change does additive bring to affect business transformation? All right, Daniel, unmute.
Always mute myself and then forget. Classic. So when we think about business change and change versus transformation, I think it's kind of good to boil it down to the base factor and then build up from there. I think of it as a foundational advantage, and then a series of understandings you can build on top of that to affect real transformation. So when we boil it down to the basics, we think about it in a pretty simple way. And this goes all the way back to the 80s when additive was invented, but even before, I have this picture of next generation, which is from the 60s and 70s, which is this idea that you can deliver a part from idea to existence in a simple way. And the way I would like to highlight it is using 3 words: automated, integrated, and observable. And these type of things, these are really key to the fundamental advantage of additive. Automated and integrated mean that you don't have to think about the actual making of your part as it's being made. And observable is really important because in 2 ways. One, you can see the part being made, or you can see the thing being fabricated. And then you can also understand how it was fabricated in a way that is only understandable via like machine intelligence or intelligence into how your machine was functioning. And those 3 things kind of provide that core fundamental advantage of additive that's been known for years or decades even. When we think about the hype cycle of additive and how in 2010, 2011, 2012, when it first started taking off, people were saying in 10 years, everything you have is going to be printed. The core bones of that statement is kind of encoded in here. It's this fundamental advantage of making a part using this automated additive platform. But obviously, this doesn't even equal any business impact. So how do businesses take this idea and turn it into value today in a kind of conventional way? So I think about it in 3 ways, or I would say 2.5 ways, because most businesses think about it in 2 ways, and some think about it in this 3rd way with regard to labor. So the 2 axes that you'll typically see companies think about additive in terms of establishing value and kind of understanding the impact of what they're doing is time and cost. And they think about it in a pretty simple way, what I would call a first order way. So they ask pretty simple questions. How much faster can we make this part? It was an 8-week lead time, now it's 2-week lead time, right? It was 6 months, now it's 3 months to do this broader thing. So that's the first thing. And the second is, how much money do we save by printing this? And then the question that is almost immediately always following that is, can we pay off the machine? We're looking at direct ROI between the parts we're making versus a previous method and the cost of the machine. And a lot of companies still will only move if they see that compelling immediate ROI. Now, there is a 3rd one that you'll see some companies think about in some ways. It's a bit grayed out because it's only used by some, which is to save labor. And so we see some companies think about kind of combining that time and cost into manpower and saying, how much fabrication labor can we eliminate, which is, we should not say, but is what some companies say, or can we free up by using 3D printing? And that is kind of the bridging the next step to these 2nd order advantages, but it's still relatively first order. It took a machinist 8 hours to machine this part. they no longer have to machine the part. They can spend 8 hours machining elsewhere. So when we think about these are how your typical company in 2020, 2021 is benchmarking additive as a solution. What we want to posit is that you can take these things, these are not wrong, but you can take these and level them up into more transformational benefits. And so when we think about this, the first one is that we can secure a competitive edge. And that's really important. So this manifests in a wide variety of ways, but two ways we highlight here is that a resilient and reliable supply chain enables you to deliver parts to customers when other companies cannot. And the second one is that you can get to market faster with additive manufacturing. And that kind of goes down to that saving time and labor bit, but brings it through the entire scope of a program, whether it be faster iterating through prototypes, faster tooling up a manufacturing cell, more like a more effective manufacturing cell that enables you to manufacture at volume more quickly. Those are all core advantages. The second one is to increase revenue and profit. So we take that cost when we really level it up again. We think about lowering costs as a function of our business, not as a function of an individual part. And one of our customers talked about how using additive manufacturing, they were able to produce the same amount of revenue with 3% less cost, and they were able to attribute it with additive. And that's not a single part savings, that is a business-wide savings. And those type of things are immensely valuable. And when you think about it that way, all of a sudden that 3% is transformational. Saving that much money on a single part may not be, but that 3% is transformational. The second is minimizing downtime. Machine shops and manufacturing floors are effective when they're working perfectly, but anyone who's been in one knows that they're rarely working perfectly. And additive can be that type of glue that holds your manufacturing floor together to make sure that you're producing revenue all the time, not 90%, not 95, 99 plus. And the last is you can reduce your inventory overhead. Additive enables you, especially digital connecting ones, to maintain a digital inventory. So instead of thinking about it as like printing a part, like having a part, printing a part versus machining it, it's I have a part in the cloud that I can produce on demand at any point at the point of need, and that's a really valuable thing. The last one we'll talk about is increasing that productivity and the efficiency of your actual manufacturing operation. Whether that is if you're making multiple parts and now you can change over from making one thing to another thing on the same line in 3 days instead of 2 weeks, that's valuable time you've gained. Whether that means that you increase the yield of your product from 90 to 95% because you're able to have more precise tooling, you're able to decrease your tolerances thanks to that. Or that means you're reducing lead times because, again, you're able to do everything a bit faster. All these type of things are the way that you sum up those core benefits we just talked about into things that are actually fundamentally transformational, that a C-level person really cares about and internalizes. But I always want to close business transformation with the most important part of any business, which is employees. And we see time and time again is that additive is empowering the people that power your business to be better employees and be more engaged and powerful employees. I have this example from Colo Manufacturing, who's a Markforged customer who is incredible, and they do really, like they are a 130-year-old manufacturer of window hardware. They've been around forever. They've been a market leader forever. And they have adopted additive with that same mentality that Nate talked about, which is that change can be really good. And top to bottom, when you talk to them, when you talk to their employees, everyone from their president down to the people who are working on their machine shop floor, they kind of speak the same language. So if you look at the top, we're talking about the president, the leader of this, the C-level person, talking about how it's removing bureaucracy and adding autonomy for his employees. He feels like this is a big tool he's using to empower them to put their thoughts into part, where it is reducing turnover, employee turnover, it's increasing engagement, it's increasing productivity beyond just the things we just talked about. When you think about going down to a director of engineering, the more tangible manager of engineers, they talk about how it brings an excitement to engineering to be able to have that printer on your desk or in your facility to produce parts and see those results where you see monkey see to monkey do. And that is an incredibly valuable change from have a design, submit it, and see it in a few weeks. And those type of things increase engagement and increase productivity. And the last is that you talk about folks on the floor who are not afraid to say they didn't know it was going to happen when they brought additive in. They were used to subtractive manufacturing and they didn't know if it was going to make their job harder, if it was going to make them become obsolete in their job. But what happened was they were able to learn it and they were become even more critical in their manufacturing operation thanks to the additive manufacturing. So you take these people from top to bottom who are traditionalists as they come, but open to change, and you turn them into more effective members of a business community. And I think that's really important. When we think about business transformation, this is the stuff that gets me most excited. Now with that, we're talking about, done talking about the theoretical, Nate's going to take you through the actual brass tacks of building an additive plan. And let me tell you, he's done this a lot of times, so he's quite good at it.
Yeah, thanks, Daniel. So, right, glad you covered why we're here, right? What we're all shooting for. And to get there, it's very important to have an additive plan. So purchasing a standalone hobby or prosumer 3D printer is not an effective way towards business transformation. I know I've been there myself. These printers usually sit on a desk of a single user who's likely to only be the only one that understands how to utilize it. Right? While it may be assisting that individual in their specific role, right, the full potential of additive really isn't being utilized. The individual becomes a bottleneck in the system, and if they were ever to leave the company, right, that means your additive efforts have gone to zero. This method seems low risk, right, due to low cost, getting going. But really, what's at stake here is the large scale additive adoption that you're missing out on. While you're tinkering with your hobby printer, trying to get maybe a successful ABS part, your competition is fully embracing additive at a business level and getting a step ahead, and that's a very big risk to be missing. So another approach, right, is to create an additive center where you've got 3D printers that are shared by the entire business, sometimes even globally. Business transformation requires everyone to fully utilize the benefits of additive, and having a remote location producing your parts for you additively is really only slightly above the traditional outsourced produced parts. Backlogs, shipping costs, long lead times are all going to be reducing utilization and putting a damper on scaled adoption. But really, all departments of your business should be welcoming additive into their standard operating procedure. So business transformation with additive is much more than just printers themselves. I'll continue to build on this vision for an additive roadmap. So you may have found your business in one of these following scenarios, or maybe you're living this right now. So if you're still waiting to use additive manufacturing, you haven't gotten your feet wet with it yet. So in this scenario, right, you're risk averse. You're fearing that your AM technology will be obsolete. You're unclear maybe just how to get started. So additive adoption requires new skills and design for additive manufacturing, right? Manufacturing cost audits and analysis, physical and digital transfer of parts. If an organization waits too long to adopt, they're not going to be prepared to integrate technology when it's fully mature. This isn't something that you can all of a sudden flip on a switch and be full bore adopted, right? It's a process, it's a transformation for your entire business. So if you've got additive manufacturing in like the R&D type ivory tower location, right, in this scenario, you've got this new technology that's confined to really only R&D pilots. It's centralized additive equipment and design expertise. It's not distributed around the entire business. And these groups tend to look at projects for future programs, not necessarily solving today's current problems. So, right, additive manufacturing adoption requires pilot 3D printing applications that are tied to tangible business values, like stuff that's actually going to make an impact today. Communication between manufacturing and R&D, which allows for identifying these high value applications, again, cross department communication, and involvement in the production cycle or the product design cycle, and immediate action on ROI and capturing the broader value at stake. Lastly here, right, if you've got decentralized additive across your organization, here additive is being used by siloed individuals, right, with minimal additive design experience. There's no central authority or ownership. Right? How are we enabling these siloed individuals? So right, additive adoption requires best practice applications and file sharing. Measuring business critical metrics, measuring the full value at stake, right? What works in one facility may easily be transferred into 10, 50, or 100 other locations. Right. These are some scenarios where you find yourself, you're not set up for success. All right. So let's talk about the blueprint for additive transformation. And there's not exactly a perfect step-by-step solution that you follow these 1, 2, 3, 4 in a row. It's not going to be that simple, but getting the general idea and covering some staples here will help you get an idea of where to start and how to succeed. All right, from the beginning of your additive journey, it's critical to think about how you'll execute at scale. So this will help others understand that this is an important plan to invest in. And key parts in your plan should include people, process, and technology. So these are some of the things that you should be asking yourself while you're on this journey here and creating your plan. So where are the pain points in your manufacturing process? Sometimes they're hard to list out on command, but when you experience them, it's immediately clear. Right? Why are you staying late? Every Friday to try and make sure your production cell is set up for the weekend, so you can go enjoy a couple of days off. Think about the tools you have available to help figure them out. Any slow points, processes aren't scalable. Where are you jerry-rigging solutions? I've been in many manufacturing facilities, seeing duct tape and zip ties. That's not a permanent solution in most cases. And those are out there for a reason, because maybe more traditional solutions were too expensive or took too long to implement. So where are you paying a premium for goods or services because there's no other option? Where are your single point failures? Identifying problems of various scales and being open-minded. Right? No problem is too small or too large. You don't need to find like the flashiest applications, right? Just focusing on functional parts. Where are you actually going to make an impact on your business values? That is something that we often see. People looking for the holy grail of 3D printing applications, and maybe that's not, it's a really difficult thing to start out on. All right, so how does this fit in your team, company, or staff's workflow day to day? How do you educate your workforce? What happens if something goes wrong or fails? You need to realize value is an active task, and it doesn't just happen. There's a lot of effort that has to go behind it. So little things such as usability and connectivity have a great impact on how a product is leveraged. Ramp up is critical. Your workforce needs to learn new skills, and you need to have a plan to provide that. So think about when you need an optimized workforce using additive. Maybe that was yesterday, right? Can you think backwards to that point logically? So having a plan for getting to a point where your entire workforce is enabled. So how does this connect to your existing tool set or tech stack? Manufacturing systems are more connected than ever before, and 3D printing is obviously no exception. And you need to think about how 3D printing will fit into that. So key thing here, right? What does success look like? And then what is your phase 2? So at the end of the day, you're going to get out of additive what you put in. If you're looking to solve small problems, that's what you're going to get out of it. If you're looking to change how your business operates in a foundational way, that reality is actually closer than it may appear. Transformation doesn't happen overnight, right? Step logically, understand phase 2 before you start phase 1. So technology is pointless without the people capable of understanding and using the equipment's capabilities. To successfully adopt additive, you need to assemble the right team. I've got a little org chart here showing from the top down, there isn't just one siloed group that's involved with additive, right? That's kind of some of the scenarios that we talked about previously that weren't going to be successful. So here are the key stakeholders in your additive team. So you've got the steering committee, right? Establish a leadership team to provide alignment to the business goals, monitor progression, and provide feedback. You need sponsors. Right? Key is having both executive sponsor, someone from the senior leadership team that can build alignment across departments, and departmental sponsors, leaders with technical know-how that can lead, empower, and keep teams accountable. One of the departmental sponsors could be your overall additive manufacturing program lead that's responsible for program success and execution. And lastly, champions are the team that's actively working with and learns the new technology, hands-on, that's being carefully selected. You need to look for high-performing engineers, material scientists, designers, people that are really amped up to get involved with this new tech. So a pro tip here, so an additive manufacturing program can be a great recruiting tool for engineers looking to join forward-thinking companies or embracing the latest technologies. Daniel mentioned, right, recent grads are being trained in additive very early on and are expecting to use these new skills and once they get into their careers. So additive manufacturing programs do not occur in engineering or manufacturing silos. It's equally important to have representation in human resources, IT security, procurement, finance, right? This is an entire business adoption. So one of the most prevalent is human resources, right? Without a bought-in and trained workforce, additive manufacturing technology is futile. Include HR early in the program so they can have tangible, so they can get tangentially communicate and train employees. So positioning a wider culture shift, right? This is crucial to get employees on board and overcome these internal risks associated with new technology adoption. Dive deeper into change management and training next. So additive manufacturing and 3D printing can be highly disruptive and to the employees in an organization. Right? The skills acquired by machine operators and even CAD designers are different. The skills required to operate a CNC machine are an order of magnitude more complex. What is required to remove parts from a print bed, perform basic maintenance on a printer, or even refill filament. To some extent, once again, for better or worse, we're transferring human skills to software-based programs. So engage HR to roll out a change management strategy in parallel to the technology adoption strategy. Got to get people excited and demonstrate that technology is not difficult to use, and it's the way of the future. Initiate a training program to educate employees on design for additive manufacturing, maintenance, and operation of 3D printers. Right, for operators, educate on the inner workings of a 3D printer and get them to learn how it works. And the maintenance and operation required for either one printer or a print farm, very similar. The designers need to deliver training on the difference for designing for traditional manufacturing, like machining or casting. Now they're going to be designing for the additive process. All right, and this brings us to the digital forge. So at Markforged, we've created what we like to call the digital forge, press, print, forge parts. The digital forge is an intuitive additive manufacturing platform for modern manufacturers, bringing the power and speed of agile software development to industrial manufacturing. Composed of software, printers, and materials working seamlessly on a unified platform. Purpose-built to integrate into your existing manufacturing ecosystem. Digital Forge adopters reap immediate benefits through massive time and money savings on parts. The digital form platform is designed to eliminate barriers between design and functional parts. Through increased adoption, the platform drives competitive advantages by making your entire operation more agile and efficient. So this truly, the entire offering with the digital forge is very unique to Markforged. Say we're here to everything we covered in this presentation here. We've got a product or a solution or a person to help out with that. So from the beginning of your additive journey, it is critical to think how you'll execute at scale. This will help others understand that this is an important plan to invest in. The key players in your plan should include people, process, and technology. So by partnering with Markforged, you can take advantage of these three key benefits. Markforged has strategic partnerships in industry and investors to launch market-driven tech solutions. Markforged puts tools in your hands to be successful along your additive journey. And with an industry-leading platform comprised of software, printers, and materials, it's the best tech for transforming your business. Markforged University offers a range of certificated courses to enable new users and accelerate adoption. These courses start with the basics of how a 3D printer functions, navigating through advanced design for additive manufacturing techniques, and how to adopt additive at scale and drive business transformation. We've seen customers very rapidly adopt additive and start thinking outside the box of how to transform their business after coming out of these courses. One of the best quotes that I've heard a customer repeat over and over is, holes don't have to be round. Why are you making round holes still? We're not using drill bits anymore. With additive, they can be different shapes. All right, so Eiger Fleet is the next generation cloud-based additive manufacturing software solutions. It helps organize and manage distributed manufacturing operations on enterprise and global scale. With Eiger Fleet, businesses can control all printers, users, and workflows with increased efficiency and insight. Things like role-based access, which enables increased operational efficiency and gains increased visibility over your team. Give the right people access to the right devices and parts, where and when they need it, based on projects and team responsibilities. Integrated and automated operations connects your 3D print solutions to other enterprise systems through APIs, so users can easily identify and print parts automatically. No additive manufacturing expertise required. Enterprise level security management applies corporate user security policies and solutions for easy, consistent identity enforcement and user management. And custom analytics enables you to track and analyze part cost and lead time for insights into additive manufacturing return on investment. Get visibility into fleet use via real-time monitoring dashboards. So all of these features, again, if you're going out and buying a standalone printer, does not come with these types of features that you can probably tell are critical for the scale adoption and business change. All right, and Blacksmith. So Blacksmith for X7 establishes and streamlines the quality process control for additively manufactured parts. And you can get to market faster with confidence in your parts by scanning parts while they print. Blacksmith brings the only industrial grade FFF3 printer with in-process part verification into your hands. This is a real game changer here. Most other platforms, you're printing a part and you have no idea how accurate they are. Are they even usable? Do they fit within your drawing dimension or drawing tolerances in GD&T? So in an automated fashion, right, as the parts are coming out of the printer, you have that data available to you. That is huge. No need for an additional manual effort to take measurements. A report is ready to print out once it comes off the build plate. So that wraps up the different segments here, talking about our additive vision. And we're on to Q&A. Anything else here, Daniel?
No, I'm good. I thank y'all for listening. I really appreciate you spending time with us. We're talking a little bit about less about, speeds and feeds and a little bit more about how you can change your stuff. So it tends to be more high level. So, if you have an abstract question or if you have something you're not sure about or just a general thing, feel free to ask it and we'll do our best to answer. See, someone asked the questions, what are some of the main motorsport companies Markforged has been working with? I don't know them off. Nate, do you know them off the top of your head? I think you've worked with more than I have.
We do have a partnership with a group called Battle Scarred Motorsports. They are in the 24 Hours of Lemons races. So maybe not exactly the type of motorsports that you're thinking of, but I've had firsthand experience in maintaining these, essentially these lemons, right, and keeping them running, printing unique custom parts, even out in the pits. So that's my firsthand experience.
Yeah, and I know a couple of other, there's a number of motorsport companies that own their printers, but I wouldn't say we like fully partner with them. But it depends. There's quite a few. I think there's a couple in IndyCar. There's a couple of international ones as well that do it as well. So a couple other questions. Someone asked some more application-centric question, which is, I'm looking at the options using additive manufacturing to produce impellers using centrifugal pumps. What is the effect of a 3D printing component operating in water and the absorption and swelling of a component? Will the absorption be an issue? So Nate, do you want to take that?
Sure. So again, this is definitely a little outside of the subjects here that we're covering, right? We're kind of talking less speeds and feeds and more about that business transformation. Um, to generally answer your question, there's the possibilities with additive are endless, right? If you understand the technology and you've things like you've gone through things like Markforged University, say start to think outside the box. Especially myself being an engineer, you tend to get blinders on sometimes when you're starting to tackle applications, and you lose track of the other possibilities. How else can you tackle your solution? Other materials that you can bring in. Maybe you're stuck on this part was traditionally aluminum and it needs to be aluminum still because that's the way we've always done it. So thinking outside the box on that is really helpful. Um, you know, Talking about your specific application, I'd be happy to chat offline to get more into the details. But I think this is getting a little off topic on the webinar here.
Yeah. All right. So I'll snag. There's like 4 questions that I think we can answer pretty quick. So I'll take them out. Does Markforged have partnerships in aviation for structural parts? Markforged works with, we have a series of companies that we work with in the aviation space now who print parts that are non-structural. I think there's one that's called Hanger One that we talk about quite a bit, more cosmetic parts. But we are currently undergoing an NCAMP certification that's due to be complete sometime in the next year or so. I don't know the exact timeline. It's hard to know the exact timeline. And I think that should unlock us for broader use in the aerospace kind of vertical. In terms of specifically structural parts, we'll see. Like I think that's a tough one. Like it's one thing to get into a plane. It's another thing to be a structural part of like a completely non-structural. It's one thing to be partially structural, and it's a whole other thing to be like a fully structural part of a plane. So we'll see with that. It's a tricky one. Someone asked if we could say more about in-process quality control. So Blacksmith is our solution for this. It's currently available on our X7 printer, which is our industrial series printer. What it does is it uses a laser on the print head to scan a part, and it scans the part as it's printing, and it generates the scan points based on the part itself. So it's able to produce a 3-dimensional scan of the part based on, even though it's on a 2-dimensional gantry. And so what that will enable you to do is then compare that against your design file. And it does some really robust and interesting things, whether it be just generally comparing the accuracy or comparing specific features, whether they be faces, holes, distances, all that kind of stuff. So we kind of started with this core scanning technology, and we're building on that to be first smarter, and then second with a vision towards being corrective in the near term. Someone asked, and then there's been a couple of interesting questions about Markforged University. So Markforged University is integrated. You can, when you have a Markforged printer, you can purchase Markforged University. It comes in various seats, and there's different, if you're a Markforged customer, there's various bundles. I'm not in sales, so I couldn't give you the exact answer of the cost, but the gist of it is we divide it into a few different segments. We have kind of a composite specific one, which is more FFF plus our special technology centric. We have a metal one, and then we kind of have a more business centric one, which is talking about the concepts we were talking about here in a bit more detail. So that's the kind of rough thing, but it goes everywhere from like the specific design details of how to design a part for additive to should I be printing this part to how does printing this part help my organization. So it's kind of the same level and abstractions that we're talking about here, zooming out. Someone asked, how competitive are the prices of Markforged filament for prototyping relative to other industry grades filament or machining MDF? Our filament tends to run on the a bit more expensive side. It would certainly be more expensive than MDF. MDF is notably very cheap, but it is it introduces a level of functionality, especially Onyx, which is our core filament, that most other 3 printing filaments and MDF cannot provide. It's just stronger, it's tougher, and it's more chemically resistant. Let's see. Okay, I'll ask Nate. I have a couple for you. How do you choose between FFF and DED, direct energy deposition with metal, ceramic, and composite printing? Do you have a way to FFF and FGF? I'm not actually familiar with FGF. Print these materials without washing and sintering. So I think they're asking roughly about the metal process.
Sure. So yeah, there's tons of different types of additive technologies out there, each having their strengths and weaknesses. So, right, FFF and DoD are very different in how the parts are being produced. So our parts do go through that three-step process, right? Print, wash, and sinter, where some of the other technologies like DED have a single process. And I'm definitely a lot less educated on these other processes. But think of things like cost of adoption. You know, how much does the hardware cost? How easily is it to adopt? What volume of, you know, what size of parts is this good at making? And what volume of these parts can you make? How many, you know, tens, hundred thousands of them do you need a year? Right, material properties. You know, we've gotten some questions in here on part density, so that needs to be taken into consideration as well. I'm not familiar with FGF either, but essentially our metal technology, as it stands right now, requires that print, wash, and sinter.
Yeah.
And answer that to my best ability.
Yeah, I think the one thing I'll say with the DED is DED is generally more metal and ceramic specific because it's more powder based. FFF is a much lower barrier of entry. If you're, you know, and barrier of entry can be for your first machine or it can be for your nth machine. It just is a matter of like where are you trying to integrate, what are you trying to do with it. So that's good. Eduardo asked a question that I missed earlier, which is that he's in the education. He's in the education of manufacturing, mostly subtractive and CNC realms. They use more hobbyist printers, MakerBots, and Dremels. How can Markforged help his program? So Nate, you've worked with folks like this before. What do you think?
Sure. Yeah. Everywhere I go, there's a range of hobby printers all the way up to industrial platform printers, and there's always you know, special interest in Markforged, and it is again what we provide with the Digital Forge. We provide everything that you need from hardware with the printers, the material offerings, software enablement. Right, we're not a company that just drops off a printer. It says good luck. Right, we've got the tools available to you to be successful. And often these groups that are using these kind of standalone, more hobby or prosumer printers, there's not that wide scale adoption, right? Again, it's siloed. So what Markforged can bring is that larger, you know, and enable you to do that larger business transformation. Again, trying to stay away from the speeds and the feeds, obviously, you know, hit on that real quick. What Markforged can bring, right? Strong end use parts, dimensionally accurate, beautiful surface finish. That you know they can say, for example, the continuous carbon fiber is something that those other kind of hobby prosumer printers are not going to bring to the table.
Yeah, cool. So a couple more questions, and then I think we'll probably wrap it up. So someone asked if FFF is limited to parts that do not require high density. Yeah, I mean, I think generally, so FF typically prints with open cell infill. You can print parts that are solid, but because of the nature of it, it's not as optimized for it. If you're thinking about in the context of metal, that's generally where you think about like density. So I'm guessing that's the field that you're discussing. FFF is generally, the design intent is to go with parts that have designed, I would call designed porosity. You have open cell infill that then centers into you know, a lattice structure inside the part. That being said, you can print solid. It's not going to be as dense as a rock part, but it is relatively fully dense. The actual number depends on the material you're printing with, but the statistics are all in our data sheets. Paul asked if we could model the material stresses of 3D printing parts in ANSYS. So we currently have an integration with we have one integration. It's not with ANSYS, but we are working towards that. Obviously, with 3D printing, it's challenging in a couple of ways. The first is the parts are fundamentally anisotropic, especially in the composite space because of the way that you're building them layer by layer. The second is that they have those internal structures. And then the third is additionally with Markforged, if you're using continuous fiber, you're using two different materials and the interaction between those materials is tricky. So we've been working on this for years and I think we'll continue working towards it. But the eventual goal obviously is to have something that can be FEA validated. And that is something that is a big unblocker for a lot of our potential stuff in the future.
So there's a couple questions here around, you know, hey, I'm in this industry looking to get an additive. How do you suggest we start experimenting? You know, and some other questions here right around our other product offerings. Hop onto our website. We've got a lot of great information on our offerings. And we can also get you in from our website, you can get in contact with so someone responsible for your industry or your area, and can get you set up with a representative, application engineer, and start talking to you about getting started, right? Going through the process, things that we identify here in this webinar here, and get you set up for success.
Yeah, and to reiterate, like a lot of the folks that have some of our largest install bases of printers started with one printer. It's not, you know, an additive plan does not have to mean that your first purchase is $1 million. It can be that you purchase a single printer, but you purchase it with intent. So when you think about like who would you think about as an additive supplier? That's a way to say, hey, we want to get into additive. We don't know exactly how. Let's look at this. Let's find a machine that we think has potential, and let's evaluate it holistically with the idea that we're going to go look more broadly. That's the key differentiator. It's that, you know, if you buy a machine with the intent of it always being that a single machine, that's what it's going to be. If you buy a machine and say, I want this to be a program, but I need to figure out how to do it. That is how most of our most successful customers start. I think that's really important. Someone asked, how does a customer customize a filament chemistry? Well, you can make your own filament. We don't support third-party filaments. There are machines that do. We find is that the actual printing of the filament is the most important part when it comes to part success, as opposed to the filament itself. And when you can kind of close that ecosystem, you can really ratchet up the quality of the part itself, but then also the way that the printer prints the part. And I think that's really important. So our formulations are all our own. We make all our material in-house in Massachusetts, and we ship it around the world. So that's our strategy. Someone asked, how does Eiger connect to other machine tools in manufacturing via ERP connector or RESTful API? We have API. We're, as part of Eiger Fleet and as part of our kind of rapid diversification of Eiger, which is our software platform, we have API connections that are actually being used by our customers today. They're kind of in the stages where they're being used by a few customers, not everyone, but we do have those, and we do have we're building these really robust connections between Eiger and MES tools and Eiger and inspection tools and all that kind of stuff. Oh, one last question before we, two more questions, I guess. Does Eiger with a scanner in Blacksmith have a digital twin? I'm not sure exactly what that means. The scanner is actually on board the machine. It's on the printer. So the print head has a laser scanner on it. It does not currently, we don't currently do it doesn't currently support like a firearm scanner. It's an onboard scanner only. That could change in the future. I'm not making those product decisions though, so I can't make any promises. And the last person asked is, how long is the lifetime of the machine? This is an interesting question. Markforged has been around for about 8 years. I know some printers in our organization that have been around for almost as long as Markforged has. I don't think that there's we have a set kind of determined lifespan for machines as a relatively young company. I think it's difficult to know that. I will say that we have each machine has consumables that are really easy to replace that do have lifetimes, and we actually monitor those on our software and let you know we need to replace things like nozzles, tubes, all that kind of stuff. So that's kind of a rough go on that. With that, and with it being almost 11 Eastern, I think we're going to finish up now. I really appreciate all of y'all coming on for this presentation, for almost 40 minutes of it and almost 20 more minutes of questions. If you have any other questions, feel free to reach out and feel free to look through our website and our stuff. You know, we'll definitely send you all some more information, but if you have a specific question, we're always willing and able to help you answer it in whatever way we can. So again, thank you so much for your time, and hope the rest of your week is great.